basically this class is going to be about 3D design. We're going to be using the software called Tinkercad, okay? Okay, hey guys, so my name is Chris Lee. I'm going to be a junior at Limbrook High School next year, or 11th grader. I live in California, San Jose. And I started 3D design when I was actually a 7th grader 4 years ago. I was introduced to it by my business class teacher, Miss Chow, and I got really into it and I began learning more and complicated softwares. And then today I've been actually teaching 3D design for almost, I think, 3-ish years. So yeah. Okay, let's just get started now on our real stuff. Hold up. Okay. Oh, by the way, one more thing, guys. If you ever have any questions, you guys can, I think there's this raise hand thing on the side or something. You can raise your hand, or you could just type it in the chat. I'll be keeping a watch on the chat. So if you have any questions, just type them in the chat. Is that okay? Hold up, I'm having some technical difficulties. Okay. All right, so what is 3D design? Does anyone know what 3D design is? Anyone? You can just like unmute yourself and answer if you know what it is. No? All right. So basically 3D design is where we use a computer, okay, and to help us design objects in 3D. And so basically you can make anything you want, okay? Anything that you can imagine, you can make it. The computer will help you make what you want, all right? So basically the more technical definition is the process of designing an object in a special software that allows you to model objects in 3D. And so basically this type of software is called CAD, which is short for computer-aided design. Okay. All right, so some CAD examples are SketchUp, Fusion 360, Inventor, and Tinkercad. I don't know if you guys have heard of any of these, but they're all pretty popular 3D designing softwares. And what we're going to be focusing on is Tinkercad, okay? By the way, you guys can all see the slides, right? Yeah? No? Say something like that.
Yeah.
Yeah? Okay. All right. All right. So basically, these two are some of my projects that I've done in Tinkercad. I don't know if you recognize any of these. Does anyone know what this thing here is? What this is?
I know what it is.
What is it?
It's that Pokemon. I think it's called Regigigas or something.
Yeah. That's right. It is Regigigas. This is what actually inspired me to start doing 3D design. In 7th grade, I made this. That's like 4 years ago. I made this, and we actually won. And I got it printed out. I can show you guys the printed model later. This one. Does anyone know what this one is? No? Well, it's a tank, obviously. It's from a game that I used to play called Tanky Online. It's kind of dead now, but yeah, I used to play this game. But this is basically the type of stuff you can do, right? You can see, you can add color to different things, and then you can make whatever you want. These are 2 examples from Fusion 360, the other software that I know how to use. This one's a basketball and then a Lego brick right here. So yeah, anything that you can imagine, you can make it. That's the power for it. All right. So what do we use 3D design for, right? We can use it for quick prototyping, like 3D printing, which I'll show you guys later. Augmented reality. Does anyone know what that is? Yeah, what's up? Eating PC. What is augmented reality?
Isn't that just like a VR where you can pretend you're swimming, but like
That is, yeah, that's very close. That's what we call virtual reality, and 3D design is also used in virtual reality. Augmented reality is a little tiny bit different. It's basically where we implement objects that we create on the computer into the real world. So like, I don't know if you guys have played Pokemon Go, but yeah, it's Pokemon Go uses the 3D models. They put it in, and then they use your camera to try to make you feel like you're actually catching Pokemon. But basically, yeah, it's used in video games, furniture shopping, yeah, lots of stuff. Okay, so I'll actually show you an example of that with my phone right now. All right, what is 3D printing? Does anyone know what this is? 3D printing? Anyone? No? Have you guys never heard of 3D printing before?
Make pizza out of a printer, like in museums.
You've actually seen someone like print a pizza? Because I
No, but
haven't
I've
actually.
I've heard of people doing that. So I just thought, you
Well,
know,
actually, that's pretty cool. I haven't actually seen one of those or played with one of those before, but yeah, basically you can print instead of printing on paper or something, you can print on a three-dimensional. You can print a three-dimensional object out instead of just a two-dimensional picture. So once you've created your file, your design on like Tinkercad or something, you can actually print it out on your printer, right? So how that works is first you create your design and you get something as what we call STL file. And this is a special file that is specific for specific for helping us put it into the slicer. Okay, this slicer is basically what turns the STL file into another file that is specific to the printer, so the printer knows what to do like and how to print it. So you can see here this animation is it's slicing the penguin into thin layers basically. So each layer is what the printer is gonna go ahead and print one at a time slowly. And all that gray stuff you see right there, that's what we call support. I'll go into that a little bit later. The gray bars right here, those are support. Okay, all right. Next, we actually print it out with 3D printer. This is actually my 3D printer right here. And yeah, and if you can look kind of closely, you can see that they're like really thin lines going horizontally across the penguin. And that's because of the 3D printer and how it prints. Remember in the slicer, it slices it into thin slices. So that's basically what's going on here. And yeah, that's how we got our plastic model. So I think I'm gonna try to show you guys how my printer works. I actually have my printer with me today, so yeah. See if I can. All right, can you guys see? Can you guys see this? Okay. All right. So basically, on my phone, there's this feature that allows me to use augmented reality. And actually, some of the stuff I have is like this. You can place like a 3D object in the real world, and then you can oh yeah, you can move around and you can put it at different locations. You can make it bigger or smaller. Well, and it's also interactive. But as you can see, even though you move around, it stays in the same place approximately, right? It doesn't move. And so this kind of shows that you actually kind of like think it's there, but really it's actually just your phone doing its thing. Let me make this bigger. Okay. Okay. No. Okay. Okay. Why are they not size? Okay. Let's try to add sure, let's do Pikachu. Okay. Um right there. What else? Do like this one. But yeah, basically, as you can see, all of them are relative in distance to each other. So even if I move like the tornado around or something, the other two will still stay in the same place because that's just the computer recognizes or my phone recognizes like the spatial orientation of these guys. So that's what I think is really cool. And your 3D models can also become like something like this, right? You can also place them in the real world if you find the software that works with it. Yeah. Okay. That right there, that blue box over there, that's my 3D printer. That right there. So I'll show you guys that right now. Okay. All right. Yeah, I'm having my little brother hold it up for me right now, so I can explain to you guys what's going on here. Okay, so this right here is a pretty cheap 3D printer. It's only $400. Okay, I'll take the chopstick. it's only $400. Let's see what's going on here. So some basic parts of a 3D printer are the build plate, which is this thing, this little square right here. The extruder head, which is this right here.
这是3D 打印机啊。
There's like actually some stuff that's coming out. Come back here, come back here. So this right here, this thing on the back right here, this is what we call the filament, and this is actually the plastic that is used to print the objects, okay? And so this plastic is actually a long spool, like kind of like a rolled up wire, but it goes up into this tube right here, goes up into here, and it goes into the extruder, which is here, and it gets melted, okay? It gets melted to a temperature of, I think, 200 degrees Celsius. So this thing is extremely hot. And that's how it slowly prints its thing. And so as the print gets like higher, taller and taller, this build plate actually needs to move down. So basically uses this motor right here to go up and down. This extruder box right here, it can move left and right and forward and backward, while the build plate moves up and down. So I'll actually start a print right now for you guys. So, all right, I'm gonna go print. Let's see. All right, so go down. Yeah, back up. All right, so right now it's making sure making sure itself is like correctly calibrated and centered in the middle of the printer, so it knows where to start. All right, let's see. Oh, it's a bit laggy. Can you stand? Yikes. Is it good? Okay, we're good. So you guys can kind of see something coming up. I kind of use a bad color. Yeah. Just wait a bit, and then we'll see some other stuff. And so sometimes actually the build platform can be heated to help the print stick better to the printer. And that's what I have right now. And basically, it helps so that the print doesn't fall off in the middle of printing. Because if it falls off in the middle of printing, it actually makes the print kind of it makes it pretty inaccurate. So you want to make sure it's as adhesive as possible. Back up a bit.
Water.
As you can see right now, the printer extruder head is actually going back and forth. So it's actually trying to layer on the first. It's trying to put on the first layer. And so basically, this is what the slicer. This is what I meant by the slicer slicing up the print. So it slices up into multiple layers for the printer to print one at a time. So this right here is the very first layer. And usually the printer does this kind of slowly so that it sticks better to the build plate. It doesn't fall off. Huh? I never turned it on. Who turned on flashlight? No one turned on flashlight. Wait, you want to turn it on? Oh, it doesn't let you in. It doesn't let you in. Okay, so right now it's moved on to the second layer, so it actually starts speeding up a little bit, and it goes faster. So first it goes around the perimeter of the object, and then it fills in the inside. You're too shaky. All right. All right. So we'll come back to that one later. I'll show you guys what it looks like when we're done. Oh, actually, before that, let me show you some of my printed projects. All right. This right here is the tank that I designed. That I showed you guys earlier. It's the exact same one. I printed it, or actually, I didn't print this one out. My mom's coworker actually helped me print this one out. Yeah, and as you can see, it can get to some pretty fine details. The color is what actually I colored on with a Sharpie. Other than that, yeah, I think it's pretty cool. And yeah, so yeah, I mean, you guys can put a lot of detail into this and still be able to print out with most of it on there. So you can see even like such a thin layer, it gets represented on the object. These are some other stuff that I've designed. This right here, this Android right here is actually something that I designed in Fusion 360, the other more complicated, the more advanced software. You can see its antenna. Those are probably the hardest to print out. And the arms connecting. And so, yeah. This is that penguin that I showed you guys earlier, except in a different color. And it's half broke off. This, I think you guys know what this is. This is a USB drive, just a really big one that I made. Yeah. All right, let's see. What else do we have? Okay, this right here is a Rubik's Cube, or not really Rubik's Cube, it's a square one, a different type of puzzle that I created. Yeah, so basically I actually printed this one out by individual parts. So these pieces were printed out individually. So one at a time, I just glued it together to make this. You can't actually turn it because it's completely glued. But other than that, yeah, you guys can see that you can basically make anything in 3D design.
Is the Pokemon there?
What was that?
The Pokemon you showed us at the beginning of the slide. Is the Pokemon there?
Pokemon? Where? Actually, I can't find it right now. So yeah, I'll show you guys later if I can find it before the end of class today. Okay. All right. For now, I think we should move on. Let's move on to back to the slides. Okay. All right. Okay. So let's get started. I'm pretty sure you guys haven't created your Tinkercad accounts yet, right? All right, so I want everyone to go to their browser, Safari, Google, whatever. Just go to Tinkercad.com. All right, so you should see something like this. Yeah, if you can check this, like, with the, hold up, what the hell's what's going on? Okay. You guys are okay. You guys asked some questions. Is $400 low quality or high quality? Honestly, I think it all depends on like settings, like for the printer. Like honestly, at the beginning, it wasn't printing that well, but once I fixed the settings a little bit, it was actually printing pretty good. And if you're only prototyping, you don't actually need that high quality of a printer, unless you're just really into the specs. You just want to get like that perfect print. What else? I mean, it's okay if you guys don't have one at home. Most people don't actually have one at home. So, yeah. How many dollars would it cost to have a good one? Yeah, it's actually a lot. Actually, the price range is insane. So somewhere I think you can even get some for like maybe $100, $200. But you do like self-assembly, you build it yourself. Or there's some that I think are like in the tens of thousands. They're like really high quality and they're resin printers. They print like differently than my printer does.
Dot dot dot.
Yeah.
Well, I'm off to win the lottery.
Yeah, I mean, if you can win the lottery, yeah, you could probably easily afford one of those. Okay. All right. Is everyone there on Tinkercad.com? I'm just gonna assume you guys are. Yeah, that looks good. That looks good. Okay. All right. Let's go. So I'm assuming you guys have. If you guys have an account, just sign in. But if you don't, click join now. It should load. It should load up a screen.
在美国现在是晚上吗？
Can people under 13 make a Tinkercad account?
Make sure you guys are following what I'm doing right now because it's gonna be a little complicated. Just like enter your region. This website's pretty trustable. So you can enter your real birthday. I'm just gonna go. I'm just gonna go with my brother's birthday.
聊了40分钟，其中告诉你，有一次我画画的时候，我还在那个呢，我还在研究这个软件呢。
Actually, if you guys, if you guys are,
好尴尬呀。
let's see, 2000. Okay, if you guys are like under 13, why is it not loading? What the heck? If you guys are under 13, you guys can enter your parents' email, and then you can get like approved like that. Or I have a code for you guys to get approved. Either way works. Okay, so you can go username, password. All right, parents' email. If you have your own email, you can enter it too, but it's really up to you. If you don't have an email, just enter your parents' email, and I can get you approved later through there. So yeah, just hit create account, and it should bring you. It should bring you to something that looks like this. There should be like a get approved now. I mean, that's if you're under 13. Get approved now. You're currently a restricted user, blah, 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 blah. Yeah. If anyone is on this screen, I can actually give you a code because I have one. All right, is everyone okay? Yeah, if you have any questions, just ask it on chat. I'm looking there right now. So once we've done this, we're gonna start, today's project is gonna be a personalized name tag. So basically you'll be able to create your own name tag and put your name on it and design it however you like. And so our agenda right here is to have you guys learn how to navigate Tinkercad, pan, orbit, and learn about a little bit about grid setup, different hotkeys, and different views. I know it sounds like a lot right now, but it isn't actually that bad. Adding moving objects, scaling, dimension objects, and color. Yeah, should be pretty fun. All right. All right, so let's get started. Can everyone create a new design? So there's a button up here that is create new design. That's right. Okay. So you should be greeted with this blue square right here. Yeah, so basically this blue square is what we call our work plane. Okay, it says right here, work plane. All right. And let's see. Basically what we can do is on this sidebar right here, there are different shapes. You can scroll through them and click on what you like and then drag it into the work plane and click again and it'll place itself. Okay, so that's how you bring shapes from the toolbar over here into the work plane. All right, so first thing, that's basically the first thing. All right, the next thing is being able to move objects. So it's pretty intuitive at this point. It's pretty self-explanatory. You can click on the object and you can hold down your left mouse click button and move it around. Oh, and by the way, I highly recommend you use a mouse because it'll be a lot easier for you to right click and left click. So if you need a mouse, you can just go grab it right now really quick. But if you don't need a mouse, you go with your trackpad, that's okay too. All right, so once you're able to move one object around, we're gonna try to move multiple objects around. So in order to do that, we need to be able to select multiple objects. So over here, we can select by single selection, which is just just by clicking one object and moving it. Or we can use shift click selection, which is selecting multiple objects and then moving it. All right, so let's try shift click selection really quick. So if I want to move both the cylinder and the cube, I can click on one of them first. And so we can tell it's selected because of this blue outline and all these widgets over here. And we can hold down the shift key on our computer and then click the other object that we want to move. And then both of these get selected. So we can see there's a blue outline on both the objects. And then we're able to move both of them around at the same time. Do we get that?
Yeah.
Okay, all right. So right now, just try practicing shift clicking. So drag like, I don't know, 3 or 4 objects out.
I missed it.
And shift click. All right, let me catch you back up. So make sure you're holding on shift when you're clicking and choose all the objects that you want to move at the same time. So if you click on shift, it'll allow you to select multiple objects and you can do something to them all at the same time. Okay, so the okay, all right. Okay, so next thing, after moving objects, we are going to learn how to scale objects. So okay, actually, just let me make sure something really quick. Can everyone move like objects? Is everyone able to move their objects? Just like say yes in the chat or something. Like, All right, so if you haven't said yes yet, I'm gonna assume that you can't move objects yet, so. No? Do you need help? Oh yeah, and by the way, if you guys need help, you can share your screen and I can point out what you guys need to do. So just like, if you want to share your screen, just like say something and I'll let you share your screen. Okay, all right, eating PC boy. Okay, so you got it. Okay, so we're good? Is everyone else okay? Yes? All right. Okay, next we're gonna do scaling objects, okay? So basically scaling objects is when if you've been wondering basically what these this white, black, and these random dots are, this is for making the object bigger and smaller. So you guys can actually try this right now. Just click any object and then just try dragging the white widget or black one around and see what it does. Different ones do different things. So yeah, just try all of them. Okay. Looks good. Try to make that cube bigger. All right, nice, nice, nice. Oh, one thing that I forgot to mention to you guys is when you move objects, if you want to move them off of the work plane, so if you want to give them like height, you can click this black triangle cone thing right here. You can drag it off the ground like that. Do you guys see that? So we can drag it up and down.
My triangle just glitched off the map. It's
Seriously?
now under it.
Oh, you mean you move the triangle underneath the work plane. I mean, it's not actually a glitch. This is an actual thing. It just means it's gone into the negative, and honestly, it's fine. But most of the time we like to keep our objects above the work plane. So you just click on the triangle and move it back up. Okay. All right. So what if we wanna make this cube bigger in all different dimensions? Okay. Let's just say we want to just make it bigger without like squishing it too much or like stretching it too much. What we can do is we can hold down the shift key on our keyboard and we can choose any of these widgets and we can just drag them and all the sides of the cube will get bigger. Do you see that? So we take any widget, we drag it, all the sides of the cube will get bigger at the same time. So then you don't need to worry about your cube not being a cube anymore. And so that's especially effective when for like something like a cylinder, if you want it to stay circular on the top, if you squish it this way too much, it becomes an ellipse or an oval. So we don't want that. What we do is we hold down shift and we expand it like that. So therefore the top of our cylinder stays circular. All right, can everyone try that right now? So once again, shift and choose any of the widgets and drag it. Okay. All right. Let's move on to a slightly more complicated concept. So I'm going to create a quick house right here. You guys don't have to do this. I'm just going to show you. Okay. So I have a house right here with a green roof and red walls, I guess. And so let's just say I want to make this house like just a lot bigger, okay? This house is too small for me and I want to make it a lot bigger. So if I try to scale up my red box first, it gets too big and I can't actually see my roof anymore. And if I scale up my roof right here, I don't know how much I need to scale up my box to be able to match that. So what you can do is you can select both of them at once using what we learned earlier, holding down shift and selecting both objects. And once you have both objects selected, you can scale them at once. So we make the house bigger, the entire thing all at once. So you can just try that with two random objects. Just any two random objects. Drag it out. And you just just hold down shift and click both of them. And they can scale them up at the same exact time without having one get too big or one get too small. All right, if you guys need help, just type in the chat, okay? Or just ask. Same thing with moving things, right? Remember, we could always hold down shift and move it. And also one more thing, depending on which widget you choose to scale it on, with holding down shift, it actually scales in a different direction. So if I held down shift and I chose this one and dragged it this way, it expands towards that direction. And this corner right here, this corner will stay in the same place. And if it's for the one at the top right here, if we scale it here, everything will get bigger everything will move except for the center point there, except for the middle point right here. Okay. Is everyone okay with this concept?
Yeah.
All right. All right, moving on. Adding dimensions. Okay, I think to me, this is one of the more important things in Tinkercad, but because it's kind of just it's not very precise Tinkercad. So I actually highly value these dimension things. And so basically what a dimension is we can click on one of these points right here and we can click on one of these numbers over here and type in a value. So say this is 40 right now. I actually want it to be a little longer, so I changed it to 60. And so that itself will change the length of the object. So depending on which widget you choose, different lengths will change. So at that one, I changed the height to 50. And so this can be especially useful if you're trying to print something out for the real world. If you're trying to do like a pencil holder or something, right? The pencil is like a certain size, so you have to make it Like for say, I don't know, what's a good size? Like maybe 20 millimeters. You need to make it. You need to make like a hole exactly 20 millimeters wide, so that it can fit a pencil. But you also don't want it too big, so that the pencil just like falls out. And the cool thing is, if you wanna scale the object at the same time you add a dimension, what you can do is you can start scaling the object. Okay, let's just say I want this cone to be 20 centimeters high, 20 millimeters high. All right, just change this to 20 right here. The cone won't scale. It'll become flatter, but it won't, the whole thing won't get smaller. So what we can do with that is we can hold down Shift and drag it down a little bit. If you can't get precise enough, if we just miss the 20 mark, we can type it in like that, and the whole thing will scale. Just make sure you're holding down Shift as you scale it as you change this value a little bit, and just type in what you want. So as long as you're holding Shift and scaling it, and then typing in the value that you actually want, it'll change, it'll scale the entire thing. All right, did we all get that? Okay, all right, I have a small trick for you guys. Not really a trick, but this is something you guys should know. So if you kind of zoom out kind of far away and you can't really see what you're working on anymore, you can hit the letter F on your keyboard and it'll bring everything back into view. And if you want to focus on a specific thing, you can click on that specific thing and hit F again, and it'll zoom you into that view. So I just remember F as in like find or focus. So that's how you remember that one. And you can also do it for objects that are behind other objects like this. Right? If I want to zoom in on this blue roof right there, or blue half cylinder, I can do that. I can hit F. It'll bring me there. And I can look around and do that. All right, so next we need to be able to look around, right? So right now I think you guys are just stuck in the single position, probably not being able to move around much. But if you haven't noticed yet, there's actually a view cube up here. This cube over here is what we call a view cube. And you can click on any of these views and it'll take you to that view. So if I click on the front, it'll move my screen to the front. And if I click on one of these arrows or something, click on one of these arrows, it'll bring me to the next side. And I can even click on an edge to give me a 45-degree angle view, or a corner, give me another angular view. Yeah, so just try that right now. Try to navigate using the view cube. And so you want to be really good at navigating things, because this is a 3D, so we want to make sure that our project is connected completely. And what I mean by that is like, all right, let me give you an example. Okay, let's just say you're building a snowman. Okay, you're building a snowman. Build a snowman right here. Okay, you got a pretty nice snowman like that, and you want to add some eyes. Okay, I'm gonna use spherical eyes just because I can. So we go over here, right? I make them a little smaller with my Shift, click, and drag. And I put them on. Right? It looks pretty good, right? It looks pretty good. Now I even add on the nose. So I go like, I make the whole thing smaller, hold down Shift and drag it down. And I want to make it a little longer, so I don't hold Shift and drag up. I can change the color here and rotate it. Let's actually see if I can rotate this. Oh, come on. Okay, all right, so I got it now. So we put it on here, like this, right? I mean, right now it doesn't look too good because it's kind of fat, but that's not the real problem, right? Everything looks like it's attached, but if we look at the side, it's actually completely not attached to our snowman body. So that's why we need to be able to move our view around to make sure everything is correctly in place. And there we go. Okay. All right. You guys can actually try to do this if you want right now. Actually, you know what? I'll let you guys do this later. Right now, I'm actually going to show you a different way to move around. So if you don't want to use a view cube, if you're not that type of person who likes to click on the sides of the cube and look around like that, sometimes it can be a bit tedious. What you can do is get your mouse and right click and drag. That'll rotate the view. Right click and drag. That'll rotate the view about basically this, do the same thing as this thing if you just clicked and drag this thing. You guys get that? Okay. All right. That's what we call orbit, making like revolutions around the object. That's what we call orbit. Okay. And so the other thing called pan, we actually do the same exact thing, except we hold down shift. When we hold down shift, we're able to move across the surface two-dimensionally. So you can kind of see it's different from pan. And we can focus in on one side of the work plane, or like the other side of the work plane, or somewhere else. And we, by combining these, we can actually kind of like focus on a single object. So if I want to go to the snowman, make sure it's in the center, pan, orbit, pan, orbit. Yeah. And this button right here, if you ever get lost, you can click home view. It'll bring you back to the original starting point of your work plane, just like when you open the document or the project. Click home and it'll bring you home. And as you probably already tried, the plus and minus over here is zooming in and zooming out. And the button over here, right underneath the home button, is the same thing that I told you earlier. It's the letter F key. It does the same exact thing. You select an object and you click it, and it'll focus in on that object. Okay, do we get that? Make sure you can click the home view. Just remember what all this does. Focuses in, or letter F, zoom in and zoom out. Okay, let's go back to the slides. So, all right. Right here, orthographic and perspective view. Does anyone know what that is? Does anyone know what perspective or orthographic means? If you know, just like unmute yourself and say it. Okay, so I'm assuming no one knows. Okay, all right. So basically, perspective view is how we see the real world, right? Closer things look smaller, and things that are closer things look bigger, and things that are more far away, they look smaller, right? And so that's how the default view in Tinkercad looks. So we kind of zoom. Let me do this. If I move this sphere, if I move this sphere over there, you can see it kind of gets smaller compared to this sphere right here, right? This sphere is smaller than this. But in orthographic terms, if we click this button over here, it switches to what they call flat view or orthographic. And if you click that, basically all the shapes are the same. So these two, even though one is farther away from the other, they look like they're in the same, there's the same distance away from us. But one is actually farther away. And so basically this is really useful if you're trying to align something so you don't have to eyeball it in perspective view. You can look at it from orthographic view and you can see everything is straight. I want the snowman to be right in the middle of our house. You can do that. But in perspective, it'd be a little harder because we don't exactly know where the middle is. So if you ever need to, switch to orthographic mode. It'll help out. But in my opinion, it doesn't look very good, so I don't use it that often. But yeah. Okay, did everyone get that?
Yeah.
Yeah? All right, if you don't understand anything, make sure you ask, okay? All right, color, I think you guys have probably figured that out by now after me doing it a bunch of times. There's this thing over here called solid. You can click on it and you can change your shape to different colors. So whatever you select, it'll be changed to that color. And let's just say if you want to select multiple things, like we do a shift selection, we can change both of them to the same color at once. And there's also custom colors. You can do it by yourself. Yeah. This thing is actually kind of new in Tinkercad. Before, when I was using it a lot, they didn't really have this. It's good that they have it now. And if you want something to be transparent, like if you're making a window on your house or something, you can access, there's actually a transparent option right here. So you can click that and then you can, all the stuff will be see-through. So as you can see, I can see that ball behind the house. Okay, yeah. Okay, so what's next? Let's see. Oh wait, if you're not muted right now, can you please mute yourself because it's causing like some bad noises. Okay. All right. Let's see. Next thing we have is grid setup. Okay, let's do that right now. So basically, right now the default grid scale is in millimeters. And so how we can see that is by actually clicking any shape and hovering over it. I think you can't see it. Okay, that's fine. We go to edit grid right here, which is in the corner over here. And then above that, below that is what we call snap grid. I'll show you guys what that means later. We go to edit grid and then we can change our units over here. If you like inches, you can use inches. Bricks, I think that's for like Minecraft or something, but you don't need that. Yeah, but I like millimeters, so I use millimeters. Presets, this is just basically the sizes of different printers. These are all printers. And so they set a width and a length for the work plane for you. So if you hit update grid, it'll change the grid to be a different size. Personally, I like the grid to just be as big as possible. I think the biggest is 1000 by 1000. So this just gives me a lot of space to work in. But it is a little bit laggier, so just make sure your computer can handle it before doing that. Okay, all right, that's basically all I have for now. So let's get into our actual project, okay? So our project is a personalized name tag. So what I want you guys to do is using all those shapes that are under basic shapes, create a name tag be as creative as possible. I know mine isn't very creative, so you guys can make different shaped name tags. Yeah, you guys have about 15 minutes, I think. That's okay. Yeah, so just make sure you're using your dimensions to make sure the name tag isn't like too big, right? Make sure it is like a normal size, and yeah. So this right now is a time for you to be creative. So go for it. Make a name tag, put your name on it. Oh, and if you need text, there's something right here. You can choose this. And you can type your name or whatever. Or if you don't like this and you want to arrange each of the letters by itself, you can go to text and numbers under this Tinkercad toolbar here, text and numbers. You get each of the individual letters. So if you want to do a name where each letter is like tilted a little bit, you can do that. Yeah. Oops. Okay. In the meanwhile, I can show you guys some of my previous students' projects or name tags that they made. Okay. Okay, I'm gonna stop screen sharing for now. I'll come back later. All right, so this is one of my previous students' name tags. This is the one that I actually just printed out. It's the mustache one. And yeah, I would have never thought of this idea, making a mustache into a name tag. That's pretty creative. Yeah, so you guys can do stuff like this. Also, you can add like small things to it, like stars or something onto the side. That's what I've seen a lot of people do. I don't know if you like hearts or something, or you can add like words onto the side of this right here, like I did. Yeah. Let's see. This is the same one. Okay, yeah. Okay. Okay. Here's another one. This one was based off of my template. And I don't think you guys can see, but there's actually words on the side of this right here. So yeah. All right, now it's up to you to be creative. Yeah. Okay. All right. Yeah. If you have any questions, make sure you ask. Okay. Hmm? Also, if you guys need help, like just more than just a question, if you need like help on a concept or something, you can always screen share and I can direct you like individually, or like, I don't know. But yeah, yeah, exactly. It's just so that I can see your screen. That's if you need help, just message me or something or say it. Yeah. So this is one of my old name tags, really basic. Yeah, if you're wondering how I got this curvy area right here, you can actually take the box and change its radius over here. You can round it out, and that's how I got this type of shape. Yeah. So just try everything. There's even this new thing that they added recently called Scribble, and you can actually draw random stuff, and it'll make that into a design. I'll do that. Personally, I think that's a little stupid, but it's up to you if you want to use it or not. And only use this if you're trying to make something really like curvy and abstract, because Tinkercad has basically no other way of doing that. But if you're trying to make something like really straight, like a sword or something, there are other ways to do that. You don't have to draw it out. Let's see what else is interesting. And if you look through all these things, all these parts over here, you can check out different like shapes. Characters are really interesting. You can put shades on your name tag. I don't know. It's up to you what you want to make. So okay, guys, so class is almost over.